Hello and welcome back. So this is the second video, which is called shaders and more shaders, and we are going to talk about well, obviously the shaders and how to use the shader manager UI or the active pipeline tracker, how we can edit and debug shaders in real time, and the frame freeze functionality that was seen a little bit in the previous video. This video is meant to be a continuation of the previous one, so if you haven't seen that one, don't skip directly to this one. Please see it, because I explain some very important things there that you need to be aware of and you need to do before you even get here. So without delaying any further, let's resume. So in the previous video we already have Vk3DVision working, we have the stereo injection working, we are targeting every single vertex shader, and obviously there are issues, right? So I'm going to start the game and continue from where we left off. Okay, my game is starting. So as you can see, we are loaded, it's 3D. I'm going to disable it just for simplicity, and yeah. So the first thing, when you press F10, like the overlay says, when it's booting up, you will see the active pipeline shaders. This is the pipeline tracker or the shader tracker or the shader manager, how you want to see it. This view is only visible if you go to the INI file and you say development mode equals true. And I put a couple of warnings there. If you keep this one always on, this will affect performance, because this will eat a lot more memory, system memory, RAM, because I don't delete any of the resources. The game says I want to destroy this one, I don't delete them, I always keep them alive, and that's because I need to use them later for swapping shaders, generating pipelines and other stuff, right? So this is only intended as a development mode, not as a full release mode or to play your fixed game in this mode, right? So first thing, probably here you'll see that the time from the original stats are jumping like crazy. And that's because of the freeze frame functionality or rendering. The moment I unfreeze it, everything goes back to normal. So let's go inside the menu and see exactly what it does. And we are here, right? So the moment I press F10, everything slows down, and you can see it's actually hitching. It's trying to slow down, but it's not fully slowed down. And that's because this is based on how the game updates the game time. So the idea here is you want to freeze the game from thinking that too much time has passed in order for you to present the same frame over and over and over and over. And this is very useful, for example, in a game where you're in a cinematic or a cutscene, which you can't pause, to actually be able to pause it and find the shader that you want to debug and fix. So yeah, that's the speed, which is currently 10% of the original speed. And I added this nice toggle which says skip present thread, or don't skip it. And if you hover it, it will say toggle it to see if it slows down the game. Some games use the present thread to advance time, while others do it from another thread. The idea is to try to freeze the game but keep the UI functional. So now if I unclick it, you see that the game time has severely slowed down. You can see from the fire here, while the flickering is the same, because technically I'm still presenting 120 frames, although the timer is now confused and tells me that I'm presenting, well, 1000 something or 600, right? The moment I resume, everything resumes from where it was. So I freeze again and I say I want to go to 1%, and now you can see the mouse is a little bit, well, sluggish. So what happens if I go and I say I want 2%, not 21, I want 2%. So you see everything is extremely slow, but I can still use my UI. I can still go to shaders. I can still do everything. So I resume, and let's see if the Doom guy can make an animation for me so I can show it better. Come on, do something. There, I freeze it, right? You can even see the motion blur. So this is the idea, to try to give you as much possible time to find the shader that's responsible for the effect and identify it, right? And try to fix it. So I'll keep it on 2 for now. If you don't like it, you can always resume, and it's normal speed. So that's the freeze time functionality. And yeah, obviously you can freeze and then you can advance little by little. You can see the moment I say next frame, the time advances a little bit. You can see it on the fires, on the bonfires. See? Tip, tip. Okay. The next thing is, before we go into disable and original, we have vertex shader, fragment shader, and compute shaders. Obviously we can track all of them, or maybe just vertex and compute, or maybe just fragments, and so on and so on. Currently I'm going just to use vertices, right? And you notice maybe that the coloring has changed here. Now it's orange. So let's put fragments, and you get an orange, a white, an orange, a white, an orange, a white. You can see by the lines that delimit. So this is a vertex shader. You can see PS vert, and this is a pixel shader, PS frag. And compute shaders actually look like CS. So, and .comp from compute. So I'm going to only keep the vertices. And you will probably, the next thing you'll notice, the double hash. So you have a regular hash and then another hash. And if you hover it, it will tell you how the shader name is actually generated. The first hash is the shader blob hash, or the hash of the shader data that was sent by the game. And the second hash is my unique shader hash identifier, which takes the shader blob hash in context with the pipeline that is being used. Because a shader without a context doesn't really mean anything. What we are interested in is to find the context where the shader is used. For example, shader X can be used to draw shadows, and then the same shader X can be used to draw geometry. Obviously you want to sterilize one, but you don't want to sterilize the other. By having unique shaders, hashes, this allows you to find the one for geometry and the one that draws shadows, and adjust them differently, right? So that's about the naming. So the first one is the shader blob, the second one is the unique one, and then you have the type, which is VS vertex shader, and the extension, which is .vert. Talking about coloring, so you see orange, white. Orange means this shader has been injected based on one of the formulas that were defined here in the INI file. White, it means it's an original shader, right? And you can filter more. You can have all shaders, you can have swap shaders. We currently don't have any swap. Injected shaders, which are the orange one, or original shaders, which are the ones that are non-injected. And in vertices, currently I don't have anything. So let's go with injected. And let's select the first one. And you have disable shader and original shader. So disable will do exactly what you think. It will disable rendering, like you see now for the UI, for that shader. So that shader doesn't output any vertices. And it's basically what you would expect, right? Original shader, reset tracking. Original shader, on the other hand, returns the shader back to its original form, which means no stereo injection. So in some cases, like here, you see part of the UI now it's non-stereo, while other is stereo. You can see some clipping there. You can see the position of the Doom guy, right? So it's black because the position is the original one, but the vertex that's responsible for shading, which is a little bit down, it's still stereo. We'll find it, yeah, which is this one. So if you would go and say, actually let's do it. So then I have apply disable. So this will basically do this, and then you have apply original and save. So these two buttons are very useful because they are meant you are meant to use them. You're quickly finding something that is you want to get rid of, or you don't like it, and then you can just go and say disable. See, like the eyes, and you say, oh, I don't want this one. I say apply disable and save, and then you are not rendering that one, right? While the original is meant to do exactly the opposite, to apply the original and save. So this is a very quick way of filtering, right? Okay, now I disabled that one, and if I go to swap, green means it's swapped, and you can see disable shader, and at some point here I just say return. I don't output anything, I completely disable the shader, right? You can also delete the shader. So deleting the shader will remove it from disk, but will not undo the pipeline inside the game. So you need to restart the game for this to actually take effect. Speaking of which, if I alt tab and go to Doom, every output shaders will get dumped here in shader swap. So in shader swap you will get, which you see is exactly the shader, you will get the output, which all the shader swaps are being loaded the next time you restart, right? So this is how you make persistent changes between runs. Okay, if I say delete, I say yes, I want to delete, it's removed from here, right? But here you need to restart the game. There is no easy way to do it fully automatically. So because this shader can be used in multiple pipelines, it's a little bit more complicated than that. So that's why you need to restart the game every time you delete a shader. So let's go to inject it again, and yeah, you have, again, you can disable, for example, this one. However, let's say that I have this vertex, because I'm only looking for vertex, and I want to find a fragment. If you hit fragment and then you say all shaders, this is your vertex and this is your fragment, and you can see the moment you're disabling the fragment, in this case you can't see anything, but in other cases, yeah, like here, you can see some flickering. So that's the pixel, this is the vertex. Yeah, so you completely remove the rendering, but if you modify the output of the pixel, you get this funny effect. And you get this funny effect because I do it on purpose. If I just return output color 0, then you don't see exactly what is drawing. It will be identical to disabling the vertex. So I did it like this, like for the UI, to actually see a meaningful way that you are actually disabling the pixel shader, the fragment shader, and not the vertex, which is responsible for drawing the vertices in the first place. And of course you can do the same thing for computes, and yeah, you get very weird effects, like this is the lining shader, and this I don't know exactly what it does. This one is exposure shader, another lining shader, and another lining, and another lining, and another lining, and another lining, right? Okay, so this gives you the functionality to actually yeah, be able to do whatever you want. So let's say now that I want to put the UI back in mono. So to do that, we go and say I want original, and let's find our original one. So actually I'm going to turn it on. So this looks like an UI one. I say apply original and save. Let's find the next one. This one is again apply original and save. This one again apply original and save. Another UI one, apply original and save. Another one, apply original and save. And I see the green circle there. which is this one, and yeah, something like that. So now let's see if, for example, we can get rid of the flickering. The flickering means that somewhere there is a double injection. So again, with original, and we should be able to get rid of the flickering. If we find the correct shader that generates that. Okay, I don't want that. I want this. So this is one that needs always to be original. Then this one also modifies the shadows here. So you can always flip and see. Apply original shaders. And the other part of the flickering should be around somewhere around here. Did I miss it? Should be one. This is also a shadow one, which you can see is doubled. Yeah, I can't seem to find it, but it's one of these. Let's look on that one. What happens if I go there? Yeah, here, see? Yeah, so that one gets rid of that one. This one requires a little bit more searching, I guess, but it's basically the same thing. So this is how you will fix a lot of effects in the game, which traditionally when you're using NVIDIA 3DVision Automatic, you would fix it in the pixel shader because of all their heuristics, which they break more stuff than they actually fix. But hey, it worked, right? So yeah, that's why don't do heuristics, do it manually. And why I believe that a fix should be made per game, not the universal stuff, because the universal stuff in general, well, you get something out of the box with almost half the performance and other weird stuff. So anyway, right, so this is how you use to track and to quickly disable or restore the original and filter out whatever you want. And now, for example, let's say I want to disable this one, right? So edit, you can always edit the shader, which means that here, if I want even more separation, I can go say multiply by 2, which will put everything by 2. Obviously it will break the other shader, but yeah, you can recompile. See, 20 is too much, I guess, but you can see it's there. So yeah, if save and recompile on the fly, which regenerates the whole pipeline. I'm going to keep it like it is. The moment you say save and apply, it actually gets moved to the swap shaders. So I think this is our shader. If I go here and I say test, save and recompile, you can see it's this one, right? If, for example, let's say you make a mistake, you get a compile error, and the shader that's used is still the old one, right? And it tells you exactly where it is. So line 180, which is line 180, GL undeclared identified because it doesn't know. 181 compilation terminated because, yeah, syntax error, no code generation. So you can undo and then apply it back. Okay, one thing that I didn't mention in the previous video, but it kind of makes more sense here. Before, we actually, in the previous one, we actually found out the uniform layout binding slot that we want to use, and I explained why. And then we said that we are going to inject our uniform buffer after finding layout set. So if I go here and I search for Vk3D, which is Vk3D params, You can see it here. So we insert it above the first one. So that's our layout, which is set 0 because we only have one set. Our binding 292, which is exactly the same binding that we specify here, which is a uniform buffer called Vk3params. It's actually a structure that contains one Vec4, which contains the stereo information. On X is the separation, on Y is the convergence, Z and W have nothing. And the custom params are actually these params that are sent from the INI file, or you can actually bind it on keys. And these are all sent one time per frame, so you can't do any interframe stuff with them, right? And the name of the variable, which is Vk3DVision, which is actually used here, and we say Vk3DVision dot stereo because we want the stereo component, or the stereo dot stereo vec4 dot x, which is separation, multiplied by GL position W minus convergence, right? And if you want to add ini files, you can say ini file, sorry, params from the ini file. You can say Vk3DVision dot custom params dot x, and that will take into account this one. And if I go and recompile now, you can see 0. So we put it back to well, mono, right? Because I'm multiplying everything. Well, not exactly, I should have done that, but anyway, you get the drift, right? So yeah, editing shaders, you can do that. So I said this is my shader, I want to find a fragment for it, which is that one, because it's always, they are always grouped together. So I say I want to edit my fragment, and I want to say out color 0. So output, if you look here, I don't know, where is it? Layout, out color is there. If I put 1, what would it give me? It doesn't give me anything. Yeah, it wasn't the best shader to select because this one doesn't output anything. Let's go for another shader that actually, yeah, and I don't want the shader, I'm going to delete it. Let's go on a fragment that actually is much more interesting. That one. I like this one. So let's say I want to, I don't need you. Let's say I want to outfrag color, right? Let's say I want to colorize this one, and to make everything red. You can see this is the motion vector, you can definitely see it. And yeah, this is the motion vector, which means it will modify the motion rather than a color. But yeah, if we do that, what happens? You can see it's fixed, that part, but it's glitchy. And like, come on, unlike this one. But yeah, this is how you debug and edit shaders in real time. Yeah, I don't want this. Let me find something much more interesting, I guess. Oh, I don't want original, I want to disable. Right, this one. Here I should be able to colorize it. Well, there are too many, but you understand. All right. Yes, I know. Okay. So, like I was saying, all the shaders are then output here, and you can see all of those that I already removed. For example, if I want to see how many times this shader is used, I can go 495 FD. That's only one time. Let's see, I don't know, 430. No, I want something much more interesting. This one. No, 7FD. Yeah, So you can see this shader is used 2 times. It's exactly the same shader, but in 2 different pipelines, right? So what does this shader do? That's disabling the fog, and this one is disabling your helmet, right? So fog and helmet. Fog, and this is a good example to see exactly how they are used. The same shader is used for 2 different separate things. So for example, you notice that the UI, which I think it does, yeah, you see we have 1A6, 1A6, 74, 74, which is the same shader, right? So if I go and say, let's not use that, I'm just showing it for reference. Let's just go and say that 74A. See, so I have this shader 3 times, right? And you can see what it's responsible. So it's clearly UI. So you can either have 3 variants of it, or you can actually keep track of it, like 74E or 74A. And then here you can actually go and say remove the unique part, and this is now the standard part, and I'm going to say this is a general shader, right? Which means that every time the game makes this shader, it will ignore the unique aspect or what pipeline it will do, and this shader will be propagated for everything. So now if I would to restart, yes, I want to restart and start again, you will see that once I will search for that hash, that you'll get the exact identical shader 3 times for 3 different contexts. Okay, yes, and I want to resume that, and I go here and I'll search. It's just easy to show it, and I go here and I filter. You'll see this is a general shader, this is a general shader, this is a general shader. It's actually 5 times, right? So I basically injected all of them, which I think it's all the UI or part of the UI. So this is the trouble, because this one is UI, this one is UI, this one I don't know, this one I don't know, this one I don't know. So that's why it's a bad idea in general to target shaders like this, and you always want to target specific shaders based on their unique IDs, because if you don't know what the shader does, you think, this will always fix shadows, but it might fix shadows 3 times, and 8 times it might break something completely different. So if you want to fix everything perfectly, you need the granularity of it, and this is how you do it, right? Now here you still have independent control. So if I go and say this is general 1 and this is general 2, right? You'll see this is general 1, this is general 2. So you can still dump them back as unique shaders. And in this case, if you have something like this, the game looks for unique shaders. If it doesn't find unique shaders, then it's defaulting back to general ones. If there is no general one, then it's just the original one. Or actually, if in case for vertices, then it will go and try to inject it. If there is no injection valid, then it's the original one. So this is how the mechanism works and how it cascades. Right, I don't think there's anything else to talk about shaders. I mean, you can find if there isn't a match, there isn't a match. Searching obviously is case sensitive, so layout. However, if you put layout, it's nothing. But if you write layo, it finds layout. So yeah. You get the log. Yeah, I think this is about it. I mean, this is all that you ever need to actually be able to fix stuff, right? And you can filter, you can search by type, if it's injected, if it's not injected. You can find the pairs between the vertex and the pixels, and computes, but obviously computes are unique, so they don't have a pair, they are standalone shader programs. So yeah, I hope you, and yeah, just to see that the UI is 2D. I hope you enjoyed this video, and how you should approach things, and how the UI works, and how everything works. And happy fixing. Catch you guys later.